Hello, good morning students. Today we'll start with cardiac cycle. Cardiac cycle it includes joint diastole, auricular systole, ventricular systole. The auricular systole it is completed in zero point 0.1 second, whereas the ventricular systole is completed in 0.3 seconds, and the joint diastole it takes 0.4 second. So total cardiac cycle is completed in 0.8 second, and therefore in 1 minute there are 32 times the cycle it operates. So see here in this figure, the blue colored structure, the blue colored part of the heart, it receives the deoxygenated blood, whereas the red color, it receives the oxygenated blood from the lungs. So during the first phase, that is the auricular systole, the auricles they contract. The left as well as the right auricle, they contract and deposit the blood to the ventricle. During the ventricular systole, the blood from the ventricle is thrown into the aorta for distribution to whole of the body as well as to the lungs with the help of the semilunar valves. This is ventricular systole. Then coming to the joint diastole. During that very period, the auricles they receive some blood, and that blood it goes to the ventricle. Half of the ventricle is almost filled during the joint diastole. So in this way the cardiac cycle it goes. So one cardiac cycle it takes 0.8 second, in which auricular systole is 0.1 second, ventricular systole is 0.3 second, joint diastole is 0.4 second. This is the structure anatomy of the heart, which shows that there are few nodal tissues which are responsible for the contraction of the heart. The first nodal tissue is known as SA node, that is sinoatrial node. Here the stimulus is there which initiates the process of contraction. It gives the information to the AV node. So we have got two important nodes in the right ventricle. This is the left atrium, this is the right atrium. So in the right auricle we have two important nodes. One is SA node, another is AV node. One is known as pacemaker, second is known as pace setter. So SA node is known as pacemaker, it initiates the stimulus, whereas AV node is known as pace setter. AV node is present in the interauricular septum and it gives the information through auriculoventricular bundle to bundle of His, and then to the Purkinje fiber which is present in the wall of both the ventricle. So the stimulus for the contraction of heart it initiates in the SA node, then it goes to the AV node. From the AV node it goes to the auriculoventricular bundle of His. It has got two branches, left and right branch, and then it is distributed to whole of the wall of the ventricle through the Purkinje fiber. So these are the four important nodal tissues which are responsible for the contraction of the heart. So cardiac cycle, in the cardiac cycle you are going to draw these four important diagrams. In the first diagram, what happens, there is a joint diastole. During the joint diastole, the blood from the precaval, postcaval, they come to the auricles. From the auricle, the blood, because the valve is open, the blood comes to the ventricle. Almost the half of the ventricle is filled. Then what happens, there is a auricular contraction, that is the auricles they throw the blood to the ventricle which is present in them. And then coming to the ventricular systole, that is the blood from the ventricle, it goes to the arteries, aortas, right, for distribution to lungs. That is, the impurified deoxygenated blood goes to the lungs, whereas the oxygenated blood goes to whole of the body. So this is regarding the complete cardiac cycles. Now coming to, it is also associated with the cardiac cycle, that is the ECG. ECG, it is studied under the heading PQRST. These are the waves which are formed by the ECG, that is the electrocardiogram. So it includes the waves P, QRS and T wave, right? So here you can say that, see, this is the heart, right? So the first wave, that is the P. The P wave is the depolarization moving from SA node through atria. That is, here the initiation, it started, it forms the P node, right? So that is this red colored, that is the auricles, they are contracted under the influence of the P wave. Then coming to the QRS complex, Q is bit down to the wave, and QRS complex, it includes ventricular depolarization and it proceeds contraction of the ventricle. Then coming to the T wave. T wave is the ventricular repolarization and occurs more slowly than the depolarization and more spread out than the QRS. QRS is narrow, whereas T wave is spread out, it is broader, right? So these are the three important waves. P wave for the depolarization moving from SA node through atria. QRS complex is ventricular depolarization and it precedes contraction. T wave, ventricular repolarization, occurs more slowly than the depolarization. Now coming to, we are having two intervals, that is PR interval, second is QT interval. PR interval, that is P and this is R, PR interval. The interval from beginning of atrial excitation and ventricular excitation. Okay? So this is the interval from beginning of the atrial excitation and the ventricle excitation, and it includes atrial depolarization and contraction, passage of impulse through intrinsic conduction system, and it lasts for 0.16 seconds. QT wave, the ventricular depolarization through repolarization, and it includes the time of the ventricular contraction. Here the ventricles, they contract. Now here you can see, that is, we'll start from the beginning, that is the first of all the P wave. Just wait for 1 second. Yes, this is P wave, auricular contraction. See here, this will come P wave. Then coming to QRST, from AV node to bundle of His to Purkinje fiber, right? And then is the, see here, the T wave, that is the repolarization of the ventricle. When it is thrown out, the blood is thrown out into the aortas. So this is how the ECG is measured. Now cardiac cycle, it involves two important sounds. One is known as lub, second is known as dub. Now what is lub? Now see here, when there is auricular contraction, the auricles, they contract, right? They throw the blood to the ventricle. The ventricles, they will start contracting. When the ventricle starts contracting, auricular ventricular valve is closed with a sound which is known as lub. That is, the closure of auricular ventricular valve produces a sound known as lub. Then the ventricles, they contract and throws the blood to the aorta by the opening of the semilunar valve present in the aorta. So blood is thrown out to the aorta. When the blood is thrown out from the ventricle to the aorta, then the repolarization of ventricle is there. The blood, it flows back towards the ventricle, but the semilunar valves, they closes with a sound known as dub, so that blood does not enter into the ventricle. So these are the two important sounds, lub and dub. Lub by closure of auriculoventricular valve, whereas dub by closure of semilunar valve in the aorta. So we can say that when there is a joint diastole, right? When the systole is there, auricles, they throw the blood to the ventricle. The ventricles, they will start contracting. So in the initial stages of ventricular contraction, there is a sound known as lub. And then when the ventricular contraction is complete, then the ventricles, they relax, and the blood from the aorta, it wants to come back, but the closure of semilunar valve does not allow the blood to go back into the ventricle. That produces the sound known as dub, and that dub is the beginning of the diastole, right? So in this way we can say that the two sounds, they are produced. This can be explained by separate graphs also. This is the heart sound. Two sounds, they are there. That is the lub and the dub. Right? This is the ECG. That is, we are having P wave, Q, R, and T wave. Then this is how the left ventricular volume, it moves. This is how the left ventricular pressure is there. Then this is how the left atrial pressure is there, green colored. And then the aortic pressure, it is depicted in this way. That is during the diastole and during the systole. And this is how the pressure it is there. Okay, how much pressure it is there during this diastole and how much pressure is there during the systole. So aortic pressure, left atrial pressure, then left ventricular pressure, then left ventricular volume, and then ECG, and then the heart sound. So this is how we can draw them in different graphs. Now coming to the cardiac output. What is cardiac output? Cardiac output is heart rate when it is multiplied by the stroke volume. It is known as the cardiac output. Heart rate, it is, for example, 72, and stroke volume, it is about 60 ml. So when we multiply them, then the cardiac output is there, right? Now there are various factors which are affecting the heart rate as well as the stroke volume. So first of all, we'll see what are the factors which are affecting the heart rates. The heart rate is affected by autonomic innervation. That is, the nerves which brings information from the brain to the heart. Then second is the hormones. Third is the fitness level. And fourth is the age. These are the various factors which are affecting the heart rate. Now the factors which are affecting the stroke volume. Stroke volume is the how much volume of blood the heart pumps in one go, right? So the stroke volume is affected by the size of the heart, then is the fitness level, then is the gender, then is the contractility, duration of contraction, then is the preload and the afterload. So these are affecting the stroke volume. So as a result of which cardiac output is affected by all these factors, because cardiac output is heart rate, multiplied by the stroke volume. So basically we can summarize the factors which are affecting the cardiac output are increase or decrease in the heart rate, changes in the posture, sympathetic nervous system activity, parasympathetic nervous system activity can also affect the cardiac output. So heart rate can vary by a factor of approximately 3, that is between 60 to 180 beats per minute. Such a variation can be there in the heart rate, that is by approximately factor 3, 60 to 180 beats, right? But the stroke volume, it varies by factor 1. Now coming to various controls. As I've told you, the control of brain is there, that is we are having various cardio-regulatory centers and chemoreceptors in medulla oblongata, which is responsible for controlling the heart, right? So these are the receptors which control the baroreceptors present on the wall of the internal carotid artery, then carotid body, which is a chemoreceptor, then the baroreceptors in the aorta, right? And then with the help of the parasympathetic nerve fiber, the SA node can be controlled. Even with the help of sympathetic nervous system, the SA node is controlled, and whole of the nodal tissue is controlled. And in addition to it, through hormones, the sympathetic nervous system, they control the adrenal medulla, which by producing epinephrine and norepinephrine controls the heart rate when it goes through the circulation to the heart. So in this way, we can say that the control of cardiac cycle, it is there. Thank you www.google.com for providing us beautiful pics so that we can explain our topic well.